Okay, in this problem we're gonna work with vectors, and we're gonna work on finding components in three-dimensional space. A rectangular plate is supported by three cables as shown in the diagram. Knowing that the tension in the cable AD, which is right here, is 429 newtons, determine the component of the force exerted on the plate at point D, down here. First up, I'm gonna work with the triangle which is right here, but I redrew it over here so I can see the dimensions a little bit better. This side is 250, 360, and this will be my hypotenuse. So I'm gonna find its distance, and these measurements are given in millimeters. So we are looking for a distance now. With the Pythagorean rule, we're gonna find h, 250 on the square plus 360 on the square over square root gives us 438.3 millimeters, and this right here, and it will be in this triangle that we're gonna use to find some components. Okay, now I'm gonna move on to this triangle, which is the one A, D, and this center right here. Maybe we should call this an O. There you go. So now we can see it better. This is O, this is D, and this is A up here. Okay, down here we just found it, it's 438. Going up, which is this side, is 480, and now we're gonna be able to determine theta, which is up here in this corner, or up here on the original drawing. For this we're gonna use tangent inverse, 438.3, which is this one, over 480, which is this one, opposite over adjacent. We are working with this angle. Calculator is going to give us 42.4 degrees. Now, since we have this one, we are able to find our next force. This is FH, which is down here, which is the force by dropping our AD force, dropping it into the plane of Z and X. So we know this angle, so the force, which is AD, I just denote it as F for simplicity, times sine of the angle, which is 42.4. And the calculator is going to give us 289.28 newtons. Now this FH is important because now with the help of FH we are able to find the component of AD in the X and in the Z direction. First, let's find our X component. AD of X will be equal to FH times the, instead of calculating alpha here, we're gonna use our ratios. 250 over 438, which is the opposite over the hypotenuse, and that one is sine. That's what we would need to find the X component right here. So FH times sine of alpha, but instead of sine of alpha we're gonna use straight the ratio of sine, and calculator is gonna give us 165 newtons, which is right here. But let's pay attention. Here we can see that our X component is going to be pointing in this direction, which is in the negative direction of the x-axis. So therefore we must put a negative over here. And we also can calculate our Y component. Actually, we could do this before we found FH. I just skipped over it. But AD, Y, it's simply our AD, which was given, times cosine of the angle that we found up here, this one, 42.4. And with the calculator we can get our y component, which is 316.8. And our last component, which will be in the z direction, coming right here, fh times, with working with alpha again, this will be our cosine. But since we don't have alpha, let's just use the ratio again. So cosine is adjacent over hypotenuse. So I'll plug in adjacent measurement, which is 360, and our hypotenuse measurement, which is 438.3. These are millimeters, and this one's our force. And the calculator is going to give us 237.6 newtons.